Hello, now we're going to learn independent sample t-test. So the learning objective of today's lecture is basically first, you're going to learn about the purpose of the independent sample t-test. Second, what is the question you can answer using independent sample t-test. How to setting up your SPSS statistic data files. And then we're going to analyzing your data. First, we need to understand there is some assumptions of independent sample t-test that we need to consider, and then we need to checking our normality, checking homogeneity or variance. So this is a two important assumption that you need to consider before conducting independent sample t-test. So that you're going to have some ideas on the effect size, and lastly, you will learn how to write your result using APA style. So the purpose of independent sample test is this test is done specifically to test for a significant difference between two independent sample means. So in this table, this is an example of how you're going to table up the independent sample t-test. In this example, here you can see that the researcher compare the epilepsy knowledge score between married and single individual. Now let us move on the what is the kind of question that can be answered using independent sample t-test. Okay, in this example, we're going to see, is there a difference of the mean BMI value between male and female groups? In this example, you're going to asking whether two independent group, male or female, have a different BMI value. So gender is our independent variable, whereby BMI is our dependent variable. In order for setting your SPSS statistic data file, click the variable view, and here you need to select the value cell for the sec variable. Use the value 1 and 2 to indicate which group each case belongs to. And then after finish, click OK. So after that, click the data view. In this example, in the data view, you need to type in your data. So please work in rows where each row represents a case. For example, participant 1 is female and her BMI was measured at 23.74 kg per meter squared. Now, we're going to analyze our data. In order to do so, you need to consider the assumption. The assumption for the independent sample test. First, scale of measurement. Your dependent variable should be interval or ratio data. Second, your data need to be independent, means each participant should participate only once in the research and should not influence the participation of others. Third, normality. Each group of scores should be approximately normally distributed. Fourth, homogeneity or variance. There should be an approximately equal amount of variability in each set of scores. Remember, the following criteria should be met before conducting an independent sample t-test. Assumption 1 and 2 are methodological and should have been addressed before and during data collection, whereby assumption 3 and 4 can be tested with SPSS statistics. So now you're going to analyze the data. So now you're going to check normality. So in order for us to analyze the normality assumption, go to descriptive analyze, click descriptive statistic, click explore. In the new dialog box appeared, bring your independent variable into dependent list. Here is BMI into dependent list and click plots. So please tick histogram on the new drop box and not forget to click the normality plot with test. If you forgot to tick normality plot with test, the Kolmogorov-Smirnov and Shapiro-Wilk test will be not calculated. Remember, Kolmogorov-Smirnov test is the hypothesis testing for checking normality. After that, click continue. Then click OK. After clicking OK, you're going to get the SPSS statistic output. So here, you will get the first table. So the case processing summary will show how many cases were analyzed and how many were dropped due to missing data. In this instance, no data were dropped. Means all data will be calculated. Under the descriptive table, the table of descriptive contains a range of useful information, including measure of central tendency and dispersion of each group of scores, along with skewness and kurtosis statistics. When skewness and kurtosis are both zero, the data are normally distributed. The skewness and kurtosis figure are reasonably close to zero. The Z skewness is 0.485 and Z kurtosis is 0.252, are reasonably close to zero. Both of Z skewness and Z kurtosis are within plus minus 1.96 for both variables. So it means that this is a good indicator for normally distributed data. So SPSS statistics provide two tests of normality that is shown in the test of normality table here. The Kolmogorov-Smirnov test is considered more appropriate for larger sample. For this example, if your sample size is small, maybe less than 30, the Shapiro-Wilk test is much more appropriate. A non-significant value is indicative of non-normal distribution. Here, Kolmogorov-Smirnov test is 0.077, means, and the p-value obtained is 0.200 for male and 0.110, and p-value go to 0.547 for female. So the normality assumption is not violated for male group, but not for female. However, the t-test is a robust test against small to moderate violation of the normality assumption. Moreover, our sample size are reasonably large, more than 30 subjects, and group size are relatively equal. If researchers concerned about several violations, they may consider data transformation, or you can use non-parametric test equivalent to independent sensitivity test, which is the Mann-Whitney-U test. From the visual assessment of histogram, they are further confirmed that each group of BMI value is approximately normally distributed. Okay, now we're going to test the homogeneity of variance and do the t-test. In order to do the t-test, go to Analyze, click Compare Means, and click Independent Sample t-test. Here, bring the body mass index into the test variable list and set into grouping variable list. So that, click Define Group, click put 1 in group 1 and 2 into group 2. In Define Group, enter the values used to represent each level of independent variable. Here, 1 equal to male and 2 equal to female. Then click continue and click OK. So this is your result. In the group statistic table, it provides basic descriptive information for each group of scores. Here, male participants indicated that on average, the BMI were measured at 23.08 kg per meter squared. The female participant average BMI value were reported a higher BMI value of 24.42 kg per meter squared. The leave-in test for equality of variance is not significant. So the leave-in test for equality of variance that I highlighted in the red box showing that the assumption of unity of variance is not violated. So therefore, you need to read the upper row of the independent stability test, which indicate equal variance assumed. So based on independent stability test, we found that the t-test equal variance assumed is not statistically significant at alpha equal to 0.05. Therefore, we fail to reject the null hypothesis. We conclude that there is no difference between the male and female BMI value. So, sometimes you also wanted to calculate the effect size. So, this is a formula of the effect size for the t-test. If the d value is less than 0.2, it's considered small effect. If the d equal to 0.5, it's considered medium effect. And if the d value is more 0.08, it's considered large effect. As the result, you can write like this. An independent stability test was used to compare the mean BMI value between male and female participants. Kolmogorov-Smirnov test was not significant for male but not for female group. However, as the sample size was reasonably large, the assumption for normality was assumed and not violated. Furthermore, when looking into the histograms, both groups showed adequate normal distributed data. Thus, observations further supporting that the data were normally distributed. Leave-in test was also not significant, thus equal variance can be assumed. The t-test was not statistically significant, indicating that the BMI values were not different between male and female participants. So this is an example of table that you can write in your thesis. With that, thank you.